Hey, it's Mr. Krenz, and in this video I'm going to go through a regression problem. This is number 5 on the worksheet if you want to follow along. So the first thing I need to do is, given the set of data, is decide whether a linear or an exponential relationship would be more appropriate. I'm always going to check for linear first because linear is a simpler relationship that people tend to understand a little bit better. To do that, I want to see if there are constant differences. So I'm going to look at the y values, and I'm going to look at the differences. So I'll label differences here. And for the differences, I want to know, when I go from the next one value to the next, is how much do I have to add or subtract. I can figure that out by doing this number minus this number. So, pull up my calculator, do 62.7 minus 96.4, negative 33.7. So I would have to subtract 33.7 to get from this y value to this y value. Go from the next one, so subtract these two values, 40.5 minus 62.7, I get negative 22.2. Right? I'll do one or two more of these. 26.7 minus 40.5, I get negative 13.8. I'm going to skip the end and do one over out here too. So 4.6 minus 6.4, get negative 1.8. Now, the important thing to notice here is that the differences are not constant. The differences are actually decreasing, which tells me that this is not linear. It's not linear data. All right. So the second thing I want to check is this exponential? Now, there is certainly the possibility that it is neither. It doesn't have to be linear or exponential. So for exponential, I'm going to look at the consecutive quotients this time. So quotient means divide. So instead of subtracting, I'm going to divide these numbers consecutively and see if the quotients are relatively constant. So I'm going to do 62.7 divided by 96.4 gives me about 0.65. Right. What that means is I would have to multiply 96.4 times 0.65 to get 62.7. I'll do this for the table, so 40.5 divided by 62.7, about 0.6 if I round in, and 0.65 again, so exactly the same. 26.7 divided by 40.5, maybe 0.66 if I round, very close to being the same. 17 divided by 26.7 is 0.64. 10.3 divided by 17 is, this one's a little bit different here, 0.61. 6.4 divided by 10.3, 0.62. And 4.6 divided by 6.4, I get a bigger one here, 0.72. The overall pattern here is that the consecutive quotients are all about the same. They're all around about 0.65, 0.66, somewhere around there. So this tells me this relationship is exponential. My explanation is, why is this exponential? It's not just because it's not linear. This is exponential, so it is exponential, full sentences here, because the consecutive quotients are relatively constant. All right. So what that means is the consecutive, so following each other, quotients, when I divide the things right next to each other, they're all about the same. That tells us we have a constant multiplier throughout. The last thing here is to actually run the regression. So that's where I need to find the equation. To do that, I'm going to pull up my calculator, and I'm going to go to my stats. So that's a statistical function. And I hit edit, and edit brings me up to this menu, and I can enter data in here. If you need to clear either the lists out, you can just arrow up so it's highlighted, hit the clear button, and then hit enter at the bottom of your calculator down here. All right, so I'll clear out both lists, and now I'm going to enter the x's in list 1 and the y's in list 2. So 1.5, 3, 4.5, 6, 7.5, 9, 10.5, and 12. Enter the y values in this list, 96.4, 62.7, 40.5, 26.7, 17, 10.3, 6.4, and 4.6. Make sure the lists match up, that the numbers that are together should be. So 4.5 and 40.5, those match up. All right, now it's to actually run the regression. So I can hit the stat button again. And now this time I want to calculate something. So I arrow over to calculate. You have a whole menu of options. There's lots of things we won't do in this class. You might guess what they do. The ones we really care about are the linear regression. So that stands for the linear regression. And then the exponential regression, which you can find. Based on the relationship that you see, you pick the appropriate function. So here I want to do exponential. I'll hit enter. Let's get rid of those things. So I just hit exponential regression, hit enter. It'll think for a second, and then it'll spit these things out. Okay. Now what this tells me is that the equation is exponential. It's y equals a times b to the x power. And then further, that here are the a and b values. Right? For now, don't worry about r squared and r if your calculator prints those out. You might talk about those sometime in statistics in the future. So a and b, I'm going to take this, write the equation. This means that I have y equals a, and a is 152.4, times b, b is 0.75, and I'm raising that to the x power. Okay. So note I am not writing down this general formula and then just a equals b equals. I'm actually translating this into the equation that models this data. Right? So what we've done in regression is we've looked at this data, we've identified a relationship that would appropriately model this, and then I have found an equation that actually fits this data relatively well.